Get ready for an unprecedented event that is quickly approaching. An enormous red giant star, located at the edge of our galaxy, is emitting mysterious signals across the universe. Using the James Webb Space Telescope, astronomers have made startling discoveries about this colossal celestial body. Renowned astrophysicist Brian Cox has issued a serious warning, raising the question: are we nearing the moment when a devastating cosmic explosion could forever change our night sky? Let's dive into the details of this enormous and thrilling event in the vastness of the universe, where stars are born, thrive, and eventually meet their dramatic end. One star, in particular, has recently captured the attention and concern of both astronomers and the general public: Betelgeuse. This red supergiant, an immense star in the Orion constellation, has fascinated observers for years with its remarkable red hue and fluctuating brightness. However, recent developments have intensified interest in this giant star, as we may be on the brink of witnessing an extraordinary event in its life cycle. But what do these changes in Betelgeuse mean? Could we be witnessing the beginning of a cosmic spectacle unlike anything we've ever seen before? Betelgeuse is roughly 1,000 times larger than our Sun, making it a celestial behemoth beyond human comprehension. To put its size into perspective, if Betelgeuse were to replace our Sun, its surface would stretch beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in its cosmic embrace. This immense size not only underscores Betelgeuse's physical enormity but also signals its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight of its existence, a phase characterized by expansion and cooling after spending billions of years fusing hydrogen into helium in its core. Though relatively young by human standards, only about 8 to 8.5 million years old, Betelgeuse is now a red supergiant due to a long history of stellar evolution. It has transitioned from a hot blue star to the cooler red-hued giant we see today. Its distinct red color comes from its cooler surface temperature, which is around 3,000 to 3,500 Kelvin, compared to the Sun's surface temperature of about 5,500 Kelvin. This lower temperature results in the reddish glow we observe. The color change itself offers valuable clues about the star's health and the processes occurring within its massive gaseous envelope. Adding to Betelgeuse's mystique is its variable brightness. As a semi-regular variable star, Betelgeuse's luminosity fluctuates in a predictable rhythm, with a short-term cycle of about 6.5 days and a longer cycle of around 5 years. These fluctuations have been recorded since at least 1836 by Sir John Herschel and possibly even earlier by indigenous cultures. However, what truly sets Betelgeuse apart is its unpredictability. Unlike most stars that follow a steady pattern, Betelgeuse occasionally deviates from its expected cycles of dimming and brightening, hinting at complex and not fully understood processes within the star. In late 2019, Betelgeuse made headlines when it began a sudden and dramatic dimming event, often referred to as the Great Dimming. Once one of the brightest stars in the night sky, Betelgeuse started to lose its brilliance at a rate of 0.1 magnitudes per day, reaching its dimmest point in February 2020. This dimming was so significant that even casual stargazers noticed the change, especially in light-polluted areas where Betelgeuse had been a fixture in the night sky. But here's the twist. When we observe a star like Betelgeuse, we're not seeing it as it is today. Due to the vast distances between us and the star, about 725 light-years away, the light we observe left Betelgeuse nearly 725 years ago. This time lag makes it challenging to detect and understand sudden changes in a star's behavior since we are essentially looking into the past. In the case of Betelgeuse, it's like watching an old movie and trying to predict the future based on what you saw in the past. Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team meticulously monitored Betelgeuse's stellar performance using the Hubble Space Telescope. They conducted a 3-year study to observe changes in the star's outer atmosphere. These observations offered crucial insights into the dynamics of a variable star like Betelgeuse, which constantly expands and contracts, causing variations in its brightness. Hubble's ultraviolet observations allowed the team to analyze layers of gas above the star's surface, heated partially by turbulent convection cells within the star. The team's analysis of Hubble's spectra from 2019 and 2020 helped measure the movement of material in Betelgeuse's outer atmosphere. They found that hot, dense material was being ejected from the star at speeds of about 200,000 miles per hour. This material eventually expanded thousands of miles from Betelgeuse, forming the dust cloud that was responsible for the star's dimming. Dupree and her team estimated that roughly twice the usual amount of material was ejected from Betelgeuse's southern hemisphere during the 3 months of the dimming event. This mass loss was substantial, especially considering that stars like Betelgeuse are already constantly shedding mass, albeit at a slower rate than our Sun. The sheer scale of this mass loss, coupled with the subsequent dimming, sparked debates among astronomers about whether this event could be a precursor to a supernova explosion. Given Betelgeuse's proximity to Earth, just 725 light-years away, such an explosion would be visible from our planet and would provide an unprecedented opportunity to study a supernova up close. However, the question remains: is this dimming an early sign of an impending supernova, or is it simply an extraordinary event in Betelgeuse's long life? Several hypotheses have been proposed to explain the sudden change. One theory suggests that Betelgeuse may be nearing the end of its life cycle, with this dimming marking the start of the supernova process. Another widely discussed possibility is that the star's outer layers were obscured by a dust cloud, which could have formed from material ejected by Betelgeuse itself. Red supergiants like Betelgeuse are known to shed material, and it's thought that this material could have created a dense dust cloud that obscured our view of the star, causing the dimming effect. A third theory posits that changes in Betelgeuse's photosphere, the visible surface layer of the star, could have caused fluctuations in its apparent brightness. To investigate this mystery, scientists employed various observational techniques, including spectroscopic methods, to gather more data on Betelgeuse's behavior. In any case, the mystery of Betelgeuse's dimming event continues to captivate astronomers and the public alike. Whether this event is simply a fascinating anomaly in the star's life cycle or a harbinger of a spectacular cosmic explosion remains to be seen, but one thing is certain: Betelgeuse is a star to watch closely in the coming years as its future unfolds. The story of Betelgeuse continues to unfold, captivating astronomers as they closely monitor this enigmatic star. Its complex behavior raises profound questions about stellar life cycles, supernova explosions, and the very nature of the universe. Betelgeuse remains a majestic celestial wonder, a colossal star whose every flicker and transformation sparks our imagination and challenges the boundaries of our understanding. Whether it signals the dawn of a monumental cosmic event or simply marks another chapter in the ongoing saga of stellar evolution, Betelgeuse serves as a cosmic beacon, reminding us of the vastness and intricacy of the universe. Recent advancements in our understanding of Betelgeuse have shed light on its intricate characteristics and hinted at future cosmic discoveries. The star's variability, especially its semi-regular dimming and brightening cycles observed since the 19th century, plays a crucial role in unraveling the mechanisms governing Betelgeuse's behavior. One of the most significant events was the star's unusual dimming in late 2019, which garnered worldwide attention and sparked intensive investigation. This rare dimming, during which Betelgeuse's brightness dropped significantly, raised critical questions about stellar evolution and potential catastrophic events, such as a supernova. Astronomers employed ground-based telescopes alongside space observatories like the Hubble Space Telescope to monitor the star's every fluctuation and atmospheric disturbance. The results of this extraordinary dimming event provided fascinating insights into Betelgeuse's outer environment. Observations revealed a rapid release of superheated material from the star's surface, forming a dense dust cloud that partially obscured its brightness. This phenomenon offered a rare glimpse into the mass loss processes of red supergiants, deepening our understanding of the factors that determine the fate of massive stars. Continued studies of Betelgeuse have uncovered intriguing changes in its chemical composition and atmospheric dynamics. Shifts in spectral lines, such as the magnesium Roman II lines, hint at the star's internal processes and ongoing evolution. These spectral investigations, combined with theoretical models and simulations, contribute to a broader understanding of Betelgeuse's complex behavior. Given its proximity to Earth, approximately 725 light-years, Betelgeuse presents a unique opportunity for detailed observation. This proximity allows astronomers to study the star's pulsations, convective movements, and interactions with the surrounding interstellar medium, providing valuable insights into the dynamics of red supergiants and their essential role in shaping the universe. One of the lingering mysteries surrounding Betelgeuse is its unpredictable fluctuations in brightness. While most red supergiants exhibit periodic changes in luminosity, Betelgeuse's erratic dimming events defy conventional explanations. The star's ongoing dimming, though spectacular, has raised concerns about the possibility of an impending supernova explosion. However, astronomers emphasize the need for continued observation and data collection to determine whether these dimming events are precursors to such catastrophic events. Additionally, studies of Betelgeuse's bow shock phenomenon have provided valuable insights into its interaction with the interstellar medium. The star's rapid motion through space generates a shockwave that shapes its overall environment, offering astronomers a unique laboratory to explore astrophysical processes at play. These investigations not only enhance our understanding of Betelgeuse but also contribute to broader studies in stellar astrophysics. In recent years, advancements in observational technology have revolutionized our ability to study stars like Betelgeuse. From ground-based telescopes equipped with adaptive optics to space-based observatories capable of capturing high-resolution images, these tools have enabled unprecedented insights into the lives of stars. Collaborative efforts among international research teams have further expanded our knowledge base, fostering a global exchange of ideas and discoveries. Looking forward, astronomers are prepared to tackle new challenges in unraveling Betelgeuse's mysteries. Future missions, such as the James Webb Space Telescope, promise to unveil further layers of the star's atmospheric composition and dynamic behavior. These efforts will shed light on the fundamental processes governing massive stars and their ultimate fate. In conclusion, Betelgeuse remains a celestial enigma that continues to captivate and inspire astronomers worldwide. Its profound impact on our understanding of stellar evolution, supernovae, and cosmic dynamics highlights its significance in astrophysical research. As we embark on future investigations of Betelgeuse and beyond, we remain poised to make new discoveries that will expand the frontiers of human knowledge and deepen our appreciation for the vastness of the universe. The temperature of Betelgeuse has recently decreased, which researchers believe may be due to a massive dark spot on its surface. This theory was supported by observations that showed a temperature drop of at least 170 Kelvin around the time of the dimming, suggesting significant surface changes. The breakthrough in understanding this unusual event came from the Hubble Space Telescope. Hubble's observations revealed that the dimming of Betelgeuse was likely caused by a massive eruption of hot material into space, forming a dust cloud that obscured part of the star's surface and reduced the amount of light reaching Earth. This dust cloud was believed to have originated from very hot plasma ejected from a large convection cell on the star's surface. As the plasma cooled, it formed dust grains that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, starting in January 2019, played a crucial role in piecing together the timeline leading up to Betelgeuse's dimming. These observations captured signs of thick, heated material traveling through the star's atmosphere in the months before the dimming occurred. By December 2019, several ground-based telescopes observed Betelgeuse's brightness decrease, particularly in its southern hemisphere. The material, initially brighter than the star's usual brilliance, eventually formed a darkening shadow as it cooled and spread outward. This outflowing material and the resulting shadow were believed to have caused the sudden dimming of the star. The scale of the event was massive, with Betelgeuse expelling an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This eruption expelled material that was several times the mass of the Moon, marking a significant event not only for Betelgeuse but for our understanding of stellar mechanics. The implications of this massive eruption challenge the conventional understanding that red supergiants lose mass at a steady rate before their explosive end. The scale of this event suggests that red supergiants may undergo a more tumultuous and unpredictable end-of-life phase. Could Betelgeuse be preparing for its dramatic final explosion, a supernova, within the next few centuries? Recent studies estimate that this could happen sooner than previously thought, possibly in just a few tens of years. Another intriguing aspect of Betelgeuse's behavior is the concept of its bow shock. As this massive star travels through space at about 67,000 miles per hour relative to the surrounding interstellar medium, it creates a bow shock, similar to the wake formed by a boat moving through water. This phenomenon occurs as the star's outer layers interact with interstellar gases and dust, providing a stunning demonstration of the star's dynamic nature and its interaction with the cosmic environment. Studying this bow shock not only helps us understand Betelgeuse's current state, but also contributes to our knowledge of stellar evolution and mass loss processes. Recent observations of Betelgeuse's behavior show that its surface has cooled and become less dense following the large eruption, leaving the star in an unstable state. Even years later, hydrodynamic simulations suggest a connection between the star's convective activity, the mass ejection, and its ongoing pulsation mode. This ongoing instability raises questions about the internal processes driving these changes and how they might unfold in the future. Additionally, Betelgeuse's observed mass loss rate is significantly higher than that of many other stars, further highlighting the unusual nature of this star's behavior.